Good morning, everyone. I think we're going to wait maybe a minute or two to see if anybody else is going to be joining us. So we'll get rolling here right around 10:02. Looking forward to chatting with you guys all about extraction booths. All right, I guess that's everyone when we got attendance, so we'll start. So welcome to the second installment of the How Extraction webinar series. If you missed our first one, it was on extraction booth or extraction facility safety rather. So really great one to go back and watch. Should be posted online if you're looking to set up an extraction facility and want a little bit more information on how to make a safe and compliant facility. But today we're going to be talking about Extraction Booth 101. Can everyone hear me all right? If you can't, you can shoot a little message in the chat and I can fix the audio. But also in that chat, if you want to post any comments that you have during this time, I can address them at the end during a little Q&A period. But a little bit about myself. My name is Emma Burns. I'm currently the inside sales manager at HAL Extraction. Have had various roles at HAL Extraction, some marketing, some sales, and some technical support. But I have a background in biology and chemistry, so it makes me, especially passionate about the subject and cannabis. So it's been great working at HAL, and looking forward to teaching you guys a little bit about our extraction rooms and extraction rooms in general. So a little bit about HAL Extraction and who we are. In 2016, Lynn Havok founded our company. Lynn is a certified industrial hygienist. And for those of you who don't know what a certified industrial hygienist is, it is someone who goes into facilities and checks them for health and safety things. So he'll go in and make sure that he's mitigating the risk for chemical and physical harm for employees. So when cannabis first was legal in Colorado and people started processing, Lynn was going in and reviewing facilities, and they were constantly failing for various reasons. Not having proper C1D1 or improper egresses, things like that, silly things that he was like, there has to be a much easier way to get this done. So that's kind of where the conception of this extraction booth came from. So an engineer, and they designed this kind of from the ground up. And since then, we've refined that product, our bread and butter product, our C1D1 booth, and third generation of it. So really refining this product to making it really specific for the cannabis industry, and design cannabis in mind to meet all those codes and regulations, and especially new codes and regulations specifically for the cannabis industry. So what are we going to talk about today? So we're going to talk about basically very brief basics of what is an extraction booth, components, and kind of what the brains of the extraction booth looks like. And then we're going to go into why are they necessary, look at code surrounding extraction booths. And then after that, we'll talk about limitations and possible alternatives to an extraction booth. And then we can kind of compare options and then go into a little bit of a Q&A. So I'll be talking for 25 to 30 minutes about extraction units in general and compliance stuff. And then we can certainly open it up to some questions and answers. So yeah, if you do have questions, feel free to post them in the chat as we go. So we will jump right in. So extraction booths. Extraction booths are really great because they're pre-engineered. That's really the best thing about them. Something pre-engineered versus something that you have to custom engineer every single product. So that would be like a custom build out. With it being pre-engineered, you have all the documentation done beforehand. So you're really just submitting a packet of documentation to the city that's already been approved and has been, the unit's been built around codes that are applicable. So really the benefit to that is you have a product approved for a specific use and you don't have to go into that code investigation and compliance investigation. You don't have to hire another engineer, another electrical engineer. It's all been done and it's all packaged together for you. So that really ties into the compliance. All those codes have been looked at. Any codes that apply to an extraction booth have been looked at in great detail, and the product is designed with that in mind. And I know with a custom build out, you can really get whatever you want. So you can design your space from the ground up. But with a prefab room, you still do get the modularity. So something like one of our rooms, there's the modularity and you can move certain components around the room. So you can move the door, you can add windows, you can move the control panel, you can add a second sensor. So there's a lot of customization to it as well. And then in addition to that modularity, it has the capability to grow with your facility. So if you decide to buy a small unit because you're just starting up in your facility and you think, hey, down the line, we need something bigger. Great, this room can grow with you. You just buy more panels and expand it. So it is still custom in a way. Of course, not completely custom, but you can make it work for your facility. Additionally, another great part of being modular is that if you don't own your facility and you're just renting a space and then something happens with that lease and you have to move, you can take it and put it on a truck and move it to your next facility and rebuild it there. So it is really your asset, doesn't belong to the building. What are key components to an extraction room? I did just a few brief ones. There are obviously more components and various components depending on what extraction booth you're using. Here are the key ones that really stand out to me. So fans, obviously you have to have airflow going through that room at all times. So you're going to have an intake and an exhaust fan. And then you'll have a sensor that's constantly detecting the gas in your room. And the case of a HAL extraction room, that sensor is always on even when you're not operating the room. In case it detects something, some sort of spill overnight, it'll kick the room on and purge that air. And then you have your alarms. You have a sound alarm and a light alarm. The sound alarm and light alarms are there to alert at different concentrations of gas in that room. So light alarm will alert you when there's 10% of that lower explosive limit, also known as the LEL. And then that sound alarm and light alarm will go off simultaneously with 25% of the lower explosive limit for your given solvent. So these components are great, but the brains of the system. So the control panel is really the brains of the system. Everything is run through here, and that's how this whole system communicates. So here are a few interesting items for at least a HAL panel that works with the panel components. So for the first one is fan speed regulation. The HAL unit specifically is designed to have modular variable airflow. So what it means is if the room is below 10% of that lower explosive limit threshold, then it's just going to run at a base air rate. If the sensor detects something above 10%, it's going to send a signal through the control panel and then out to the fans to speed up the fans. And again, that sensor will also send a signal to the control panel, and that's going to turn the light alarm on as well. And then if you reach 25%, then that sensor is still going to be sending a signal, but that sound alarm is going to go off as well. The great thing about this fan speed is you're not dumping a bunch of preconditioned air out into the environment all the time. So you're at that base airflow rate. You're saving energy and power by just running at the base airflow rate and only ramping up that airspeed when you have that hazardous environment created. And then lastly, equipment interlocks. There's several different types of equipment interlocks, and these were designed with codes in mind, and there's flexibility, and it's configurable to everyone's local regulations. Some jurisdictions are going to require more interlocks than others, but a panel like ours has many spare relays for you to have those interlocks. So a couple examples of our interlocks would be the fan and light interlock. So the fan and light interlock is that you can have lights on without the fan. And so that's a code that requires that. There's a code that says you can't be in this room operating with fans being on. So that's the interlocks. After the fan and lights, then you have a heater ancillary component interlock. And with that, a lot of jurisdictions will require that you have those shut off when you get to maybe that 25% threshold. It is dependent on your jurisdiction. Some might be stricter and require it at a lower threshold. Some might require it only when your fire suppression goes off. But you can interlock any components into our control panel. So if some condition is met within the room, it shuts off that equipment. And then the last interlock is a fire panel interlock. And with that fire panel interlock, if your fire suppression system goes off, you can have control panel send a signal to your building fire alarm. And that building fire alarm will send a signal to your fire department, and then they can come to on site. So that is, again, dependent on your jurisdiction. Some might require it and some might not. Some might require it at 25% to call the fire department. Some might require it only when the fire suppression goes off. So I would always say check in with your authority having jurisdiction to see what they want from you and to see, what what codes they want you to follow. So we have these main components and the brains, but here's the fire suppression system. Also, another very important part of the room, not as far as how it goes, that's standard with the room, but the reason it's not included in most rooms is because there are various options to go about it. So you can utilize an automatic building sprinkler system. So if you have a water-based sprinkler system within your building, you can add extra sprinkler heads and then duct them certain area booth, and then tie into that building panel, again, tie into the control panel on our unit, and then use that sprinkler system for the room. The most common alternative to that would be a standalone powder-based system. So a lot of our customers use a nitrogen-based powder. And so this is a standalone option. You have tanks on the side of the room, and then you have some nozzles in the room, and they're activated. So they're heat activated, the links snap, and then you get then a release of that suppressant. There are specific places that you'll need to have sprinkler heads, but for most companies, you're going to get plans where they have already laid out where they want those sprinklers as part of that full design packet. And then the last option, which is less common, I believe only to the fact that it's much more expensive, but it's a clean agent system. So a clean agent system can be utilized same way as a dry powder system. It's a standalone option, not tied into the building, but it uses a different suppressant that doesn't damage your extraction equipment or your biomass nearly as much. We've actually had a customer that has had the powder-based system go off, but really didn't have too much of an issue, recovering their equipment and getting their equipment back into good shape. So there's many options for fire suppression, but it is compulsory to have fire suppression within these rooms. So we know about the room, but why do we use it? By using flammable solvents, so let's say butane, propane, ethanol, we'll go with those three, at a volume that exceeds laboratory scale, you're creating a hazardous environment. So if you're using a quantity that exceeds that laboratory scale, you're creating a hazardous environment, and that hazardous environment requires sort of classified. So we'll go through and talk about the two different classified spaces that I'm sure most of you have heard of, C1D1 and C1D2. We'll kind of talk about what's a C1 and what makes a C1D2 and what you're going to want to put in each of those. And then we'll talk about the codes surrounding rooms and how they're designed with these codes in mind. And then we'll talk about certifications you can get on an extraction room. So we'll start with the most fun, C1D1. So C1D1 is a rating for a classification for a room. So it's an electrical classification. So you have to have rated electrical equipment that is non-sparking. So generally, you will see at AHJ requiring you to have or to house Class 1A solvents in a C1D1. So example of Class 1A would be pentane, butane, propane. So for our example, we'll use butane. Butane is a vapor at room temperature. So if you're opening any of your vessels and you have, butane escape, it's going to escape into your room as a vapor. Vapor is much more combustible than a liquid. So having those concentrations of vapor in the room is more dangerous than having concentrations of liquid solvent in the room. So it's dispersed through the air, so you have this large surface area to volume ratio of those vapor particles and make them highly combustible and can really cause an explosion if you're not using the proper rated electrical and proper ventilation. But the C1D1 aspect of this just covers the electroplating. So that's C1D1. What you have on the screen are the three main conditions set by NFPA 70, which is National Electric Code, but that's how they define C1D1. Moving along to C1D2. It's a lower rating than C1D1, but it still is rated electrical, and it's not just, your average kitchen electrical. Generally, what you're going to see required in C1D2 rooms would be something like ethanol or isopropyl alcohol. For the uses of cannabis extraction, we generally see, ethanol. Ethanol is a liquid at room temperature. So if you're opening a vessel, you're not going to have a quick leak of liquid. You would have a quick leak of gas. So you would have to have something more drastic happen to your system to spill a bunch of ethanol. And then at that, you also have ethanol as a liquid at room temperature. So it's less combustible, less surface area to volume ratio with that oxygen surrounding it. So it's not going to ignite the same way a vaporized gas will. So it's inherently less dangerous. That doesn't mean that you can't create a safe environment for these Class 1A solvents like butane. It just means that, you have to follow stricter precautions like C1D1. So here is just a quick example of one of our C1D1 booths and one of our C1D2 hoods. In the C1D2, on the right, you see they're using ethanol and some post-processing. And then in the booth on the left, they're running some C1D1 equipment in there and some rotary evaporators as well. The door generally wouldn't be open, but it's open for this picture because it should be a closed environment. And so as the hemp industry is growing, we've seen kind of an uptick of customers using ethanol. So we're now creating a product that is a C1D2 booth, so larger space to process using ethanol as well. But you have an option for C1D1 and C1D2. It's just a matter of making sure you're following the guidelines of your jurisdiction. Some jurisdictions are going to request that you put your ethanol in a C1D1, and that might seem crazy to you. And hey, I don't need that, but if that's what your fire marshal's requesting, you're going to have to go with that option. So it's really important, again, to communicate with them and figure out what they're going to want from you. So the classifications. Here I've pointed out some NFPA codes, a number of NFPA codes that are very important and applicable to extraction facilities and rooms. I'm just going to go through a couple of them, point out some key factors that we've kept in mind in designing a room, and most companies would keep in mind in designing a room. So for in NFPA 33, there's some verbiage as to what sort of material these rooms can be made out of. And then they also make a mention to the not allowing the lower explosive limit to exceed 25%. So obviously the room has been designed to keep that below 25% by purging that air constantly, starting at 10% so it doesn't build to that 25%. You'll see that 25% threshold in a lot of codes. So it's a very important one. And then I have NFPA 70, and that's the National Electric Code, and that's where both of those definitions for C1 and C1D and C1D2 come from. And then NFPA 1, Chapter 38 is very interesting because it's the first cannabis-specific code, National Fire Protection Code. So it calls for a lot of different things, and I think it's interesting to look at these because these are very cannabis specific. They call for a lot of those interlocks added about earlier. They want the lights and the fans to be interlocked. They want ancillary components to be interlocked, like heaters and chillers, and they want the fire system to be out. They also call for emergency power for the booth. So our booths have emergency backup power to the lights and the sensors, standard, and then you can add additional to back up the entire booth. But that's something that this new code calls for and was not called for in the other NFPA codes, is that emergency backup power in case there is power failure. And then they also call for that you go over that 20% lower explosive limit threshold. So again, we see that code, very important one, and we'll see it again as well. Here are other applicable codes that are not NFPA codes. They are International Fire Code and California Fire Code, which are pretty similar. So again, at the beginning of that one, they'll call out that 25% threshold. You cannot go over that. And then within this code, they call out certain standards for sensors and control units. So UL 2075 is called out within IFC and CFC for a sensor rating. So your sensor has to be up to that UL 2075 standard per IFC. And then they also call out for your control unit, your control units have to both be up to UL 2017 and UL 864. So HAL extraction, all of our control panels are those UL ratings. And then the last UL one is UL 1389, which is really a standard created for the cannabis industry and cannabis equipment. The third is for plant oil extraction equipment for installations and uses in ordinary and hazardous locations. So our HAL unit carries a UL certification as a whole. And that UL certification is saying that we're up to that UL 1389 standard. Lastly, we'll talk about certifications. So there's several different ways you can get certifications, but this is, this is sign off on those drug sets that have been pre-done for you. If you're familiar in this industry, you're definitely familiar with PSI, big name in the third-party purers. I believe they're licensed in most states that are either recreationally legal and medical for cannabis use. They will stamp off on drawings, and then that goes to your city, and you say that your city can see it and say, okay, an engineer or professional engineer has signed off on this. This is safe. Another route to go is getting a nationally recognized testing laboratory to sign off on your equipment as well. How Extraction has both of those. Underwriters Laboratory is nationally known. So in these newer markets, we have projected that this is going to be a more important list as the industry matures, because everybody knows who UL is, especially fire marshals who have no idea anything about this industry. Seeing something like UL really gives them that like vote of good faith for that piece of equipment. So now we'll move into limitations of the booth. These are not definitive limitations, but these are kind of standard limitations that you'd see on a basic extraction booth. So these two things, fire ratings, control areas, and MAQs kind of all go hand in hand. Our booths at least don't have a standard 1 hour fire rating. But when you have a 1 hour fire rating on your 1D1 enclosure, that creates its own control area. So as far as a control area goes, in each given control area, allowed to have 150 pounds of class 1A flammable solvent. So something like butane, you could have 150 pounds. By placing it into that control area, or by placing it into that ventilated space, you then can double it. By placing fire suppression on that system, then you can double it again, right? So now you have an allotted 600 pounds of butane. But what if you need more than 600 pounds in your entire facility? So if you need to utilize more than 600 pounds in your entire facility, you're going to need to utilize multiple control areas. By placing a couple unrated, like not fire rated, booths together does not give you separate control areas. So having a 1 hour fire rated unit would be a lot easier, because then they would all be separate control areas. It's not a possible hurdle to get over for modular units, but it does add quite a bit of money. So I think from what I've seen, when people run into the issue of fire ratings, they tend to think about going down a different avenue, but it's certainly something that extraction booths can accommodate, but it's generally one of those initial limitations. Lastly, we'll do just a little comparison of booths versus build outs, and then we can kind of chat about it and see if anybody has any thoughts and questions. But booths are, pre-engineered. They're going to get you to quickly. You have that drawing set ready to submit to the city. They're cost conscious because they're prefabricated, and you have all those components. You're not sourcing them yourself, and you can get up and running within a month between purchasing and setting this thing up. And then the benefit to build outs is they're complete custom. You can make it whatever you want to fit any facility, and you can crank up the fire rating and transfer facility into a place that you can have exceed those maximal level quantities. So there's a lot you can do with build outs, but they tend to take a lot more time, and they do end up being a bit more costly. But definitely benefits to both. But the booth really is that get to market, pre-engineered. It's really going to work with you and grow with you. And then I'd be happy to answer any questions that you might have. I see that I have a couple. So for Andy, I'd asked about space conditioning heater, extraction room equipment heater. So it would be an equipment heater or an equipment chiller. Those are sometimes needed to be turned off given certain conditions. We see a lot of people, if they reach that 25% threshold, those heaters, those ancillary components that wouldn't be inside the room, but would be connected to the equipment inside the room. They would need to shut off so that that system can shut down. And if that doesn't answer your question, Andy, I could definitely delve further into that. And then Jack, operators are not supposed to be in the room when fire suppression system is added. I believe the nitrogen-based system that we use, for the most part, is it gives a 10-second delay. So those those things snap, and I think there's an alarm, and you have a 10-second delay to leave the room so operators can get out of the room because it is hazardous. And it does also turn off the fans, so then you don't just exhaust all of that fire suppressant into the atmosphere as well, and it actually puts out the fire. And then the nitrogen powder-based system that we most commonly use is a Monarch or a Pyrochem system. And if anybody has any other questions, I will type. I don't know that my contact info is on this next slide, but I will type my email. Oh no, my email is on there. So my email is on the next slide. So if you want to send me any other emails, I'm happy to answer any other questions. And Andy, cannabis odor control options, you can certainly integrate something like a carbon filter into your ducting. And at least for the halo extraction units, our fans are sized to accommodate enough static pressure that you can integrate some filtration into your ducts. So our units have 100 linear feet per minute across the bottom 12 inches of the bottom 12 inches of the room, more than 100 linear feet per minute. So we do address the aerosity requirements in that way. And then you can do capture velocity testing as well on each of our units, and some of our customers do that as well. Thank you all for attending today. Yeah, and if there are any other questions, please don't hesitate to reach out to me. I'm happy to chat and explain extraction booths. And yes, there will be a recording of this webinar uploaded, I think, to this site, Matthew, or they're going to be posted on our HAL website. Some clients, Andy, will use this for grinding biomass, but most customers are doing that in a separate space just to not get more dust into the space, because that is also hazardous. Having small particles are also flammable. Most of our customers are off-gassing within the current room, but kind of poses a bit of an issue at this point, because if you're off-gassing a lot of biomass that still has some residual solvent in it, it kind of will crank up that lower explosive limit in the room. So we're actually currently in the development phase of making an off-gassing room that will connect directly to the HAL room, and then you can just put biomass in there, and it has a dedicated fan and sensor, and then you can off-gas that in a separate space, so you're not adding more flammable solvent to a working environment. And that should be available within a few months. Okay, so great. Thank you all for joining today. Again, happy to answer questions. Give me a call, shoot me an email. There will be this slideshow will be posted webinar either on our website or back on Webinar Jam. I think you might get an email with it sent. But thanks for being here, and tune in. We should have a webinar in our series coming up here shortly in the next few weeks. So hope everyone has a good afternoon and is staying safe and healthy. Everyone.